Okay guys, so before you actually get the worksheet for today, the 12.1 formulas for volume, surface area, and everything, first you need to remember that the perimeter is the distance around an object or a shape in 2 dimension. So if you have a square, or if you have a pentagon, or if you have a hexagon, or whatever shape you have, if you're trying to find the perimeter, all you do is add all the sides. So if you had this square, for instance, and it's 7 and 6, no, it wouldn't be a square then. If it's 7 on all sides, if it's a square, then 7 plus 7 plus 7 plus 7 would be 28. So the perimeter of that square would be 28. If you had this pentagon and it was a regular pentagon, that means all sides are the same. So if it was 8 on all sides, then 8, 8, 8, 8, and 8, that would be 40. So that would be its perimeter. So perimeter just means add all the sides. Unless you are dealing with a circle, then the word changes from perimeter to circumference. F-E-R-E-N-C-E, circumference. So you've got your circle. The perimeter or the circumference of a circle is always your formula, pi times diameter. So diameter is the distance all the way across. And if this circle, for instance, had a diameter of 10, your circumference would just equal 10 pi. I like to leave it using the pi, but if you wanted to, you could just type it in a calculator and do 10 pi and get your answer. Or you could do 10 times 3.14. Most of the time, though, like I say, just leave it as 10 pi, or you can type it in and get the exact number into a calculator. So that's perimeter. Next, the area. Area of shapes depends on what they are. So you should know basic formulas for area. If you're trying to find the area of a square, it's not length times width. I mean, technically you can use length times width, but usually for area, it's just whatever the side is, so I'm going to say S, then this side would be the same. So area of a square is just side squared, side times side. If you have a rectangle, that's when you use your length times width. So that would be LW. If you're using the area of a circle is not pi d, it's pi r squared. That's the area of a circle. So the r would be the radius of the circle, and the d stands for diameter when you're using circumference. So those are basic ones you should know, as well as the area of a triangle is 1/2 base times height. And that's all I can think of right now off the top of my head. You should also know the area of a parallelogram. So area of a parallelogram, which is just parallelogram, looks like this. That means this side's parallel to this side and this side's parallel to this side. So the area of a parallelogram is little b times h, where on this parallelogram the height is your altitude, like in triangles whenever we come out of the vertex. We went to the opposite side and went perpendicular. It's the same thing on a parallelogram. So this would be your height, and then your base would be what you're going perpendicular to. So this right here is going to be your base. So you would just do base times height. The area of a trapezoid. Trapezoids look like the little stand, if you go to the circus, that the little man stands on. So there's one trapezoid. Area of a trapezoid is 1/2 times b1 plus b2 times the height. So your b1 and your b2 are the two lines that are parallel to each other. It doesn't matter which one you call b1, b2. So if this is b1, then this would be b2. And then your height, again, is perpendicular to the base. So that would be your height. Sometimes you might have to use Pythagorean theorem, say if you were given this measure and this measure, or not that measure and that measure, but if you were given that measure and that measure, then you'd have to find the height of the trapezoid. But most of the time you'll be given it. So area and perimeter, that's two-dimensional shapes. So that is useful whenever you move forward into learning all of the surface area and volume formulas, and that's what's on worksheet 12.1. So if you'll get that, then we'll start looking at some. So on three-dimensional figures, that's where you use surface area and volume. So a three-dimensional figure obviously is 3D, and it occupies space. So the easiest one would be a cube. Cube looks like this. Cubes have all sides the same. So this length is S, this length is S, this length is S. It's 3 dimensions. And it's a length, width, and a height. In this particular case, on a cube, when you're trying to find the volume of a cube, how much space it contains, or how much will fill the cube, like air-wise, then volume of a cube is just side cubed. Kind of like with area, it was S squared. With volume, it's side cubed. Now that's how much will fill the cube. If you are wanting to paint the cube or put wallpaper up in a room that's a square or a cubical shape, then you would have to do the surface area. And the surface area is a pretty simple formula because all sides of this cube are a square. So this is one square. So you just look at it like the area of a square is side squared. Well, how many squares are on this cube? There are 6 of them. So that's the surface area of a cube. You just take your dimension and plug it in. Type it in a calculator, you got your answer. Let's see. So this is beneficial for surface area when you're painting, when you're doing anything around the edges. And while I'm thinking about it, an edge are the lines right here. Those are all 4 edges. So I've got 4 vertical edges. Here would be my floor. So there's 4 on the floor. And then there's 4 edges on the ceiling. So if you're trying to figure out what an edge is on a cube, there's 4 on top, 4 on bottom, 4 going around vertically. So there's 12 edges on a cube. So an edge is basically just like the sides right there. Vertices are the points or the corners. So this would be a vertice, that's a vertice, that's a vertice in green, that's a vertice, that's a vertice, that's a vertice, that's a vertice, and that's a vertice. So there are 8 vertices. 8 vertices. And then the other thing is the faces, and I think I already said it. The faces are what's shaded there in red. So you have the face that's looking at you, the face in the back, the face on the left and the right, and the face on the top and the bottom. So in a cube, there's going to be 6 faces. So this is just like a dice. Throughout this packet, each page has a square on one, either the left or the right side. And there are formulas for surface area and volume of all kinds of different shapes. So on the front page, that's where you look at your vertices, faces, and edges. And then if you flip it, it says calculate the vertices of the solid, so there's another problem. And then on the right-hand side, you've got vocabulary. So there's surface area of a polyhedron, lateral area of a polyhedron, a cylinder, right cylinder, lateral area of a cylinder. So you can read all that. I know you can. And then you flip it over, and I'm looking on a page that says 224 in the left-hand corner. And there's surface area of a prism. So the formula for surface area of a prism should be right there. Yeah, S equals 2B plus PH. B, this capital B, is the area of the base. So on all these prisms, whatever the base shape is, you find the area in 2 dimension. Then this P right here is the perimeter of the base. So this is the area of the base, and this is the perimeter of the base. Perimeter of base. The H, of course, is the height of the 3-dimensional shape. So since it's a prism, you can have the triangular prism or you can have the regular rectangular prism. And that's what 1, 2, and 3 say right there. Then on the right-hand side, you have the surface area of a cylinder. Surface area of a cylinder for SA, surface area, is equal to 2 pi r, which is radius, squared, plus 2 pi rh. This is one that you should know, like the back of your hand, because it's a common one. It stands for, on a cylinder, it has 2 circles on top and bottom, so that's where the 2 pi r squared comes into, because that's the area of the top and bottom. There's 2 of them. And then the 2 pi rh stands for your lateral area. So if you unwound a cylinder like a soup can, that would represent like the label on a soup can. So you just simply plug in the numbers in a formula and type it in a calculator. If you flip the page, you have another box with all kinds of information. And then you have surface area of a pyramid. So for a pyramid, it's S equals capital B, again, capital B is area of the base, plus 1/2 big P, again, is perimeter of the base. And then you have that funky looking L. That right there stands for your lateral area, so it's like your slant height. That's what, if you look at the example on the top right on page 227, it says 6 feet. That's like, if you slant it, let's see if I can draw it. I'm not the artist on these, so you got your pyramid right here. That looks really bad. So there's a pyramid. So the slant height is how far it is from the edge right here going slanted to the top of the pyramid. So ignore my bad art. But that's the slant height. And then again, type it in a calculator, you got your answer. That one's not a common one. If they give you that on the final, then, or if they had a problem based on this on the final, more than likely they'll give you that formula. But another common one that you should know, well no, this one isn't one, I'm sorry. For a cone, they probably would give you it, and I'm saying probably, it's not guaranteed. Surface area for a cone is pi r squared plus pi rl. So r again is your radius, l is your slant height. Not the vertical height, but the slant height. And then on the right hand side, page 229, it starts going into volume. So surface area is the outer faces, like if you're painting a shape. It's how much space it occupies on the outside, like material to make it. Volume is how much space it takes up on the inside. So you should know definitely volume of a rectangular prism, length, width, height. That one's common sense. You should also know volume of a cylinder. A cylinder is pi r squared h. So those two are there on page 229. If you flip the page, there's some more examples. I already gave you volume of a cube. That's the edge cubed or side cubed. And then you have volume of a pyramid. So volume of a pyramid is going to be equal to 1/3 big B h. So again, big B is the area of the base, and then h is your height. Volume of a cone is going to be, volume for a cone is 1/3 pi r squared h, which on a cone, pi r squared, that part is the circle, which is just the area of a circle, which goes back to 1/3 big B h. So either one of those works for a cone. I like the bottom one personally. And then the last thing in this packet, if you flip the page to 235, it's on the right-hand side. That would be a sphere. So on a sphere or a ball or the earth or something like that, for a sphere, I can actually draw it. The surface area, so how much material to make it, formula is 4 pi r squared. And then if you flip the page, the volume of a sphere is 4/3 pi r cubed. So in saying all this, you can use perimeter for the distance around 2D shapes. You can use area for the space that the 2D shape occupies. You can use the surface area for how much material a 3D object takes to build or something, or painting a wall. The material to make a bouncy ball. Those might actually have stuff inside them. The material it takes to make a beach ball, how about that? The air you put inside a beach ball would be your volume. So you can use that in reference. So you will have a select amount of these to do, and then when you finish these, you will also be given a worksheet that says surface area and volume mixed word problems. On these word problems, you need to draw a picture. So always draw a picture of what you're dealing with. That way you know what shape it is. So obviously, since it says surface area and volume, they're going to be three-dimensional. That should give you a key. And then you need to, after drawing the picture, you need to write a formula. So write the formula. Then after you write the formula, then you need to plug in the numbers that go where they're supposed to go. Plug in numbers. And then solve it. So there will be 4 answers for each of these 10 problems. Make sure you draw a picture and be careful on number 8 that says Kissy needs to paint the top and sides of a rectangular prism. So if you have a rectangular prism, here would be in a rectangular prism. If you're only painting the top and the sides, oops, I lost one of my edges there. There it is. If you're only painting the top, if you'll let me color, there's the top and the side. So here's the front, there's the right side, and then you got your back side, and then you have your left side. You're not painting the bottom. So if you're thinking of this like a room, you're going to paint your ceiling and your walls. You're not painting your floors. So be careful, because some formulas, like this one, surface area of a rectangular prism is 2LW plus 2LH plus 2WH. But in this case, you're not painting the floor. So if you're not painting the floor, you don't have 2 of each of these sides. So if I label my picture for you, if this is my length right here, and this is my width, and this is my height, my 3 dimensions, then I have 2 HWs, because that would be my front walls. I have 2 LHs, but I only have 1 W. Wait a minute, not WL. I think I said that wrong. I have 2 H, so that's the height times the width. I have 2 HLs, because that's my 4 walls. So 2, oh, my marker isn't working. 2 HWs, so I got those. I got 2 LHs. But when you think about the floor, this is length by width. There's only one of them. I'm only painting the ceiling. So you would change the magical formula, and it would just be LW plus 2LH plus 2WH. So sometimes you have to modify the formulas, so be careful when you're reading them. So you have all 10 of those, as well as the selected ones from the other worksheet. Have fun!